Now I'll switch off the video so that we can record it better. Now, we were talking about a relative configuration. So relative configuration means relative configuration, you are relating the configuration of your compound or any compound with that of D plus glyceraldehyde. This is what is meant by relative configuration. You are relating the configuration of your compound with that of D plus glyceraldehyde. So the principle of relative configuration is relative configuration is relating the configuration or comparing the configuration of a molecule with the configuration of the of D plus glyceraldehyde. And that is shown here. So this is the configuration of D plus glyceraldehyde, and it is having a plus rotation, experimentally found. So the glyceraldehyde which is naturally obtained is arbitrarily fixed, assumed. It is assumed that it is having this configuration. It is assumed that it is having this configuration. Now you compare this with a compound of your choice. Suppose, let us look at glucose. Look at glucose. So this compound is having D configuration. Now look at glucose. You have to draw the glucose with the most oxidized group on the top. CHO is the most oxidized group. Now you arrange all the other H and OH. Least oxidized group is CH2OH, and that is there at the bottom. Now look only the alpha carbon, only the carbon next to the CH2OH. Look at the carbon next to the CH2OH and compare the H and OH with that of glyceraldehyde. Now in the glyceraldehyde, H is on the left hand side, OH is on the right hand side. Here also H is on the left hand side, OH is on the right hand side. So this molecule is D. And you know this molecule glucose is having a plus rotation. This is from the experiment in the laboratory. So this you call as D plus glucose. This is called D plus glucose. Okay. Now, if you want to have the L configuration of this molecule. What you can do is you can change only this place, capital L. This carbon you change. If you change this carbon to this, you can call this as L configuration. But remember, you cannot talk anything about this. That is a disadvantage of this configuration method. That's a disadvantage. Okay, you cannot get any information about the other carbons. You can look only at the information of these carbons. And you cannot say whether this is plus or not, plus or minus. You have to take this molecule and go to the laboratory. But one thing I will tell you, if you take the mirror image of this, if you take the mirror image of this, what is a mirror image? Look at this mirror image. OH, H, H, OH, and then OH and H, and CH. This one, if you have this, definitely this is going to have L configuration, that is correct. Right? This is L configuration. And one more thing, this is definitely going to have negative rotation. Because this is exact mirror image of this, which is non-superimposable. Therefore, this compound is L minus glucose. Is that clear to you? So this is what is meant by absolute configuration, relative configuration. Now, there is one more terminology which we have to, which is there in your book. I don't know what somebody is going to use it or not. In this one, there is a term used as erythro and trio. Just like your D and L, trio. Now look at this one. The erythro and trio compares the two carbons here. These two carbons. That is, see here. If you have a molecule with least oxidized group like this and HOH, HOH. Okay, and the mirror image of this OH, OH, H and H, CH2OH. Now you can have a different arrangement for this. The arrangement can be CH2OH, HOH, and OH. And the mirror image of this one. See here. These two, you have the same group on same side in both of this. So you call this as erythro. Same groups on the two carbons only on two carbons. So same groups on same groups on same side. Okay. Now here, these two are known as trio. So trio means same groups on opposite side. Same groups are opposite. Okay. So you have to consider only the first two carbons. So that's a disadvantage of this relative configuration. So you have DL, capital L, small d, small l, erythro and trio. But remember, these methods will not describe the configuration of all the carbons in the molecule. For that purpose, we have to assign the configuration of each carbon in a molecule with a specific method which is called absolute configuration. Absolute configuration. Absolute configuration. It is also known as RS configuration. Capital S, capital R. RS configuration. Now, assigning this configuration, there is a method. There is a 3, 4, 5 steps are there. I will just write each step here. Step number 1. Identify the chiral carbons in the molecule. Identify the chiral carbons. Suppose you have IBR. Remember, you have two hydrogen atoms, one iodine and one bromine, not chiral. It is not chiral. But if you have a molecule like this, so now look at this carbon. In the central carbon, you have one hydrogen, one OH, one COH, and one CH3 on the same. So this is a chiral carbon. So you have identified, yes, you have confirmed that the compound is having a chiral carbon. Otherwise, you'll be wasting your time. Unnecessarily wasting your time. Second, number 2. Identify the 4 different atoms and groups on the chiral carbon. 4 different atoms and groups. This is the second step. So you can give them as 1, 2, 3, 4. Let me put here in this molecule. We have hydrogen, we have OH, we have COOH, okay. So 4 groups we have identified. We have identified 4 groups. Now, once after identification of the 4 groups, next you have to assign the priorities of each group. Assign the priority for each group. That is the next step. So, number 3, assign the priorities. Assign the priorities. Based on, can you see the board now? Can you see the board? കാണുന്നുണ്ടോ കുട്ടികളെ ബോർഡ് കാണുന്നുണ്ടോ ആ ഡിസ്കണക്ട് ആയിപ്പോയി അതുകൊണ്ട് ചോദിച്ചു Okay, now assign the priorities to each of this group. To each of the group by the atomic number of the atom attached. By the atomic number of the atom attached to the carbon. Atomic number of the atom attached to the carbon, to the chiral carbon. If both of them, if 2 of them are identical, if 2 of them are identical, see the next atom. And assign the priority. Now let us now see here. This OH is attached to the carbon. H is attached to the carbon. Here the carbon is attached to the carbon, and this carbon is also attached to the carbon. So we have, which are the atoms? H, O, C, and C. See, that is attached on the molecule. CH3. Suppose this is the molecule. Suppose this is the molecule which we are talking about. Okay, so this is the molecule. The COH is to the front, OH is back, H is on the top, CH is on the left hand side. Okay, now which is having the maximum atomic number? oxygen. Oxygen is 16, carbon is 12. Again, the carbon is 12, and oxygen, hydrogen is 1. So hydrogen gets least priority, number 4. There are 4 groups only. Now, highest priority for the OH group. Now, look at the next one. Both the carbons have got 12. So now you have to go for the next atom. Go for the next atom. Right? Now, this carbon is having oxygen as the next atom. This carbon is having hydrogen as the next atom. Okay. So you have oxygen. So this is the first priority group. The oxygen wala is having the second priority group. And the CH3 gets the third priority group. And H as the fourth priority. So you have assigned the priority. So let me assign the priority here. This is 1. This is 2. And this is 3. Okay. Now, the most crucial step is this one, which everyone forgets. Almost many students forget. Rotate the molecule. Don't break the bond. Just rotate the molecule. With least priority group away from the observer. So that least priority group is away from the observer. Okay, the least priority group is away from the observer. What does that mean? You have to bring the hydrogen to the place of OH. Am I right? Okay, so in this molecule, you have to bring the hydrogen to the place of OH. So we have already discussed this before, how to rotate the molecule. You can interchange the groups in this way. Look here. Remember, this is possible. So we are just rotating these 3. Right? So my CH3 remains the same. Remember, we are not changing the CH3. Now, which group comes on the top? COOH comes on the top. And where does the OH grow? OH will go to the place of COH. And your H will be behind. And that is what we want. H is behind. So you have done that job. Now step number 5. Start from 1 to 2 to 3. If you are moving clockwise, the compound is having R configuration. If you are moving counterclockwise, counterclockwise. It is having S configuration. Oh, the writing is not proper. Because the connection is very vague. So if it is counterclockwise, it is having S configuration. Now let us see here. Now see the priority, it should not change. Remember that we have the top priority for the, what is the OH group? Oh, this is the OH group, sorry. Be very careful what the mistake which we all do. Let me, yes. So this one is the OH group. So this is the highest priority 1 and 2 and 3 and this is 4. 4 you don't have to, because 4 is actually behind you, exactly behind. Now move from 1 to 2, 3. So actually the 4 is away from you. That is, the molecule will look like this here. All the 3 groups will be pointed towards you. And now where is the A? Where is the hydrogen? Hydrogen is exactly behind this. This carbon is concealing the hydrogen. So we have OH, COOH, and CH3. Now you move from 1 to 2 to 3. 1, 2, and 3. What is the direction of movement? It is counterclockwise. Counterclockwise. So the molecule is having S configuration. The molecule is having S configuration. Okay. Now the same thing I can repeat. We can do this with a Fisher projection. We can do this with a Fisher projection. Look here. Okay. Now, in this case, here it is very simple. In the sense, the actual molecule is looking like this. See here. And see here. This is the actual molecule from a Fisher projection. So you can see the hydrogen is already behind. Hydrogen is already behind. So you just have to draw it like this. CH3. It is very easy. COH. OH. Okay, now assembly priority 1, 2, and 3. Again, this also is S. Okay, so this is H. This molecule is having S configuration. So this is how you can find out. Suppose you have 2 groups. Identify the absolute configuration of this carbon and this carbon. Now here you have to see one thing. Look at this carbon first. What are the 4 different groups and atoms? Identify that. So for this carbon, this I will put this is 1, this is 2, this is 3, and this is 4. So carbon number 2, we'll look at this carbon first. C2. Which are the 4 different atoms and groups? You have OH, CHO. Then you have this big group, H, C, OH, and CH3. This large group is there. And what is the 4th group? Hydrogen. Now look at this one. OH, it's of course OH gets the highest priority. OH gets highest priority. Then you have CHO. Here you have CHO, and here you have this whole group. Now look at this one. Here is carbon, both are having carbon. One is oxygen and a hydrogen. Remember, the double bond is considered as 2 single bonds with the same atom. Here you have only 1 oxygen, 1 hydrogen, and 1 CH3. Now this double bond is considered as 2 single bonds. So let me wipe off this one. So here is 1 oxygen and second oxygen. So consider as 2 single bonds. Now see, you have 2 oxygens here, you have only 1 oxygen here. So that means this gets the higher priority over this group. So this is 1, this is 2, this is 3, and H is 4. Now see at this carbon, this is the major problem. Look at this. In this Fisher projection, the hydrogen is towards you. The hydrogen is towards you. So you have to bring the hydrogen back to the backside. Okay? So that is one method. To bring the hydrogen to the backside, what you have to do is just exchange these 3. This you bring here, and this you bring here. Okay? Now see, H is here, H we have brought to the back, OH is here, and CHO is here. Remember, we are not worried about this carbon at present. I think the time will be over just now. Okay, it's all right. Now see here, priority 1, priority 2, and priority 3. Now 1 to 2 to 3. So this is our configuration. Similarly, let us look at this carbon. This carbon again, 1. This is priority 2. This whole group is having priority 2. And this is priority 3. But again, the hydrogen is behind. So we'll have to bring the hydrogen to the front. To the back side. So shift this, and this. Okay. So you will have This H will come here. H comes here. CH3 goes here. And OH comes here. Now assembly priority is H is behind. So this is number 1. This group, the whole group is number 2. Sorry. And this is number 3. So 1 to 2 to 3 is R. Okay. So this one is RR configuration. Now how will you give the name? How will you give the name? The naming you can give like this. See here. CHO. H. OH. OH and CH2. So this is 2R, 3R,